Hello everyone, welcome to Chemistry by Ms. Nidhi Banga. Today we will be talking about oxidizing agents. Oxidizing agents, as we know, are the ones which oxidize others, and in doing so, they get reduced by themselves. So we have these many oxidizing agents that we will be covering today. We have alkaline KMnO4, acidified K2Cr2O7, chromium trioxide in dilute H2SO4, PCC, chromyl chloride in carbon disulfide, chromium oxide in acetic anhydride, Tollens reagent and Fellings reagent. Some of them are very strong, some of them are mild. We will cover them and we'll see which ones are most useful in which cases. So let's begin. Here in oxidizing agents, you'll see that most of them, they have a metal ion in a very highly positive oxidation state. For example, K2Cr2O7, in fact, chromium trioxide, chromyl chloride, they all are, and KMnO4, they all have very high oxidation state. Here chromium is in +6 oxidation state. You may also know that chromium has another oxidation state which is also very stable, which is chromium +3. So when K2Cr2O7 reacts with a substance, it gets reduced from +6 to +3, and in doing so, it oxidizes the other substance. Similarly, when potassium permanganate reacts with a substance, manganese here from +7 goes to +2, +4 or +6 depending upon the medium, but a lower oxidation state nevertheless. It gets reduced to a lower oxidation state and therefore the other substance gets oxidized, right? So this is the whole logic behind oxidizing agents. Now here I have arranged these organic compounds ranging from most reduced to most oxidized. We will see how they can be converted into each other using oxidizing agents. So first we will cover the first three, KMnO4, acidified K2Cr2O7 and chromium trioxide in dilute H2SO4, also called as Jones reagent. The first three, these three, are very, very strong oxidizing agents. So strong that they can convert alcohols to carboxylic acids directly. So alkaline KMnO4, acidified K2Cr2O7, CrO3 in presence of dilute H2SO4, aqueous medium that is. This is also called as Jones reagent. In fact, even HNO3 can achieve this conversion. So these are the strong oxidizing agents which can be used to convert alcohols directly to carboxylic acids. But if we have to convert alcohols to aldehydes or ketones, then what do we use? When we have alcohols, the primary alcohol, that can be converted into aldehyde by using a comparatively milder oxidizing agent, PCC. PCC also has chromium in +6 oxidation state, but the medium is non-aqueous, which restricts the oxidation to aldehyde stage. Similarly, secondary alcohol can be converted into ketones again by using PCC. Here, same concept, non-aqueous medium would restrict the oxidation to ketones. It will not allow it to go further. Now, if we have to convert aldehydes into carboxylic acids, then the medium that we have to use or the oxidizing agent that we have to use can be very mild. We can use Tollens reagent, which has a silver ion, Ag+, which will get reduced to Ag, metallic silver, and in doing so it will oxidize aldehyde to carboxylic acid. We can also use Fellings reagent. which has copper in +2 oxidation state. In this reaction, Felling's reagent will go from +2 oxidation state to plus oxidation state, +1 oxidation state. That means reduction, and therefore aldehyde will get oxidized to carboxylic acid. But point to be noted here is that aromatic aldehydes such as benzaldehyde will not be acted upon by Felling's reagent. Felling reagent will not be able to carry out this conversion. Tollens can, Felling's cannot. Okay. Apart from these mild oxidizing agents, we can use strong oxidizing agents as well, because oxidation cannot go beyond that. So mild or strong aldehyde can only be converted into carboxylic acid. So we can use any other strong oxidizing agent as well. HNO3, KMNO4, K2Cr2O7, anything. But when we talk about ketones, ketones are not so easy to oxidize. So we cannot use tollens and Felling's for ketones. They can be oxidized to carboxylic acid only by strong oxidizing agents. Okay, like KMNO4, K2Cr2O7, HNO3, etc. Now, when we talk about conversion of alkanes to alcohols, when we talk about this conversion, especially aliphatic conversion, then this cannot be carried out that easily. I mean, in one step. We have to convert this into haloalkanes, RX, by chlorination in presence of UV light. The mechanism used here would be free radical mechanism. And once we have haloalkanes, then from haloalkanes, alcohols can be made by simply allowing them to react with aqueous NaOH or KOH. The mechanism here would be nucleophilic substitution. Now, when we talk about aromatic hydrocarbons, such as toluene, then they can be converted into benzaldehyde in a single step. And it will need the oxidizing agent, which is chromyl chloride. But in carbon disulfide, non-aqueous medium. So see, in non-aqueous medium, chromium, even though it's in +6 oxidation state, it will restrict the oxidation till aldehyde state. It will not allow the oxidation to go further to benzoic acid state because the medium is non-aqueous. This reaction is also a name reaction. We call it Etod reaction. Then toluene can also be converted into benzaldehyde again by chromium trioxide and acetic anhydride. Right? Again, oxidation state of chromium here is +6, but the medium is non-aqueous. Therefore, the oxidation is restricted to benzaldehyde. Now, if we have to convert toluene or any other alkyl benzene to benzoic acid, then regardless of the length of the alkyl chain on benzene, it can be converted into benzoic acid by simply using KMNO4 with KOH, that is alkaline KMNO4. Here, any alkyl benzene will first be converted into potassium salt of benzoic acid, then upon hydrolysis, it will give you benzoic acid. So here, I think I've covered it all. We have covered all these oxidizing agents, the conditions in which they are useful. Go ahead and watch it 2-3 times. Try to make it on your own. And I hope it will help. Thank you.